Okay, so let's go ahead. We're going to review real quickly the stuff that you're going to expect to see on your exam or on your test that's coming up. So you know that there's going to be the angle relationship. So we have
French-Zheng.
Yes, ma'am.
Are we supposed to copy this?
If you want to copy it, that's up to you, but this is just me going through so that you're prepared and ready. Okay? All right. So angle relationships. Who can tell me what's one of the angle relationships that we discussed?
Wait, what do you mean?
Like, what relationship is it?
Oh, I forgot their names. Supplementary.
Well, it's not supplementary. It's the other one, complementary.
Oh yeah, that one's complementary.
Yeah. So this is complementary. That means it's going to add up 90 degrees. So if you take A and add B, I'm going to start muting some of you guys, okay? Because some of you are pretty loud. Just unmute when you want, okay? Complementary. There. All right, so we have complementary. This is the one that you just mentioned before, Abigail. This is the supplementary.
Mm-hmm.
You take A and add B, it's going to equal 180.
Yeah.
Okay. And then we had this relationship. Who can remember what this one was called?
Vertical.
Vertical. Very good. So this one's vertical. That means that A is equal to B. A is going to be equal to B. So you've got all these different relationships that you're going to need to make sure that you know and understand, and how to set up an equation for it. So if I said that you have the following, 3x and say 66. These are vertical angles. Since they're vertical, that means that we do need to go ahead and set them equal to each other. So 3x would be equal to 66, and then you would just solve for x. What would x be in this case?
Wait, for vertical?
Yeah. If we've got 3x is equal to 66, what would that be?
That would be... Hold on.
Well, all we would have to do is divide, right?
Yeah.
We would just divide. So 66 divided by 3. That's going to give you the 22.
Yeah.
Okay. All right, let's take a look at another relationship. So if we've got the L shape, remember the L shape forms that complementary set.
Complementary.
Yeah, so if this is 2x and this is 56. So the relationship here says that I need to add these two angles together and set it equal to 90 degrees because it's complementary. So this is 2x plus 56 is equal to 90. And then you would just have to go ahead and solve that. Okay, so if we were to work this problem out, Jimmy, what is the first step that we would need to do? So go ahead and unmute yourself and tell me what's the first step to solving this problem.
Inverse operation.
And what would that be?
We subtract 56 from 90.
Very good. So we're going to subtract 56 from 90. Okay, so if we do 90 minus 56, that's going to give us 34.
Yeah, got it
now
right.
We have 2x is equal to 34. Okay, Sanaya, what would you get? What would be the next step to solving this problem?
Divide.
And what are we going to divide both sides by?
34 divided by 2x.
Well, just by 2, right? We want to leave the x where it is, so we're just going to divide it by 2. Okay, so that would give us x equaling 17 in this case. Okay, so that's the whole gist of what you're going to be doing as part of your test. Okay, it is all multiple choice. You're going to be solving your angle relationships, so you need to know, when do you set them equal to each other? When do you set it by adding them and setting it equal to 90? And when do you add them together and set it equal to 180? You have to know the difference between those kinds of problems. And I'm going to be creating a Nearpod for you guys to work on Monday, so that way you guys can get more practice on that.
Mm-hmm.
Okay? Are there any questions on the angle relationship so far?
Wait, like on complementary, can you just like put, like, for example, like the first one, 2x plus 56 equals 90. Can you just put 90 minus 56?
Yeah, you could just do 90 minus 56 and then set 2x equal to that. That's fine. But some of the questions might ask you, what's the equation going to look like? It might not even be asking you to solve it. It just might be asking you, what is the correct setup for the equation? In which case, this right here, the 2x plus 56 equals 90, that would be your correct setup. So some of the questions you might be solving, some questions you might just be telling them how to properly set it up. Okay? So you need to make sure that you understand that kind of difference. All right, let's go on to the triangular sum theorem. So you had 2 theorems for triangles that we've discussed. The first theorem that we discussed was the triangle sum theorem. And the triangle sum theorem basically states, I just wrote triangle again. The triangle sum theorem basically states that you can take all 3 angles inside of a triangle, so angle X, angle Y, and angle Z, and if you add those together, if you add X, add Y, and add Z, what is it always going to be equal to?
180.
180, good. So that's all the triangle sum theorem is telling us, that if you add the angles together, it's going to have to equal 180. No matter what kind of triangle it is, it's always going to be equal to 180. So you might also be solving for a missing angle. So maybe you've got X and you've got 88 degrees and you've got 64 degrees. So to set this equation up, we know it's going to be 2x plus 88 plus 64, and that's going to be equal to 180 degrees. Now, in a situation like this, obviously, there's something we could do first before we start solving it. We could go ahead and combine the 88 and the 64 together.
Yeah.
So we could add those measurements together, 88 and 64 together. That's going to give us what?
152.
152, good. So we get 2x plus 152 is equal to 180, and then we just go ahead and start solving. We do our inverse operation, which would be to subtract first. We would subtract the 152 from both sides, and that would give you 2x is now equal to 28. And then you would divide both sides by the 2, and you would get x is going to be equal, to 14. Okay, so you've got that kind of process. That was the triangle sum theorem. Then we had the one that we learned most recently this week, which was the triangle inequality theorem. Okay, so now the triangle inequality has nothing to do with the angles. It has everything to do with the side measurements. So that if we've got a triangle, let's say this is A, this is B, and this is C, and A and B are the smallest sides, C is the largest. So if this is the truth, if A and B are your smallest sides and C is your largest side, then when you add A and B together, it has to be greater than the value of C.
Or else it won't make a triangle.
Otherwise, it won't make a triangle. That's correct. So I wish I had my connecting sticks. My kids have taken them now. They have become a toy to them. But if I had them, remember I was showing you guys that when I had measurements that were equal to the longest side, it could not form a triangle. When I had measurements that were smaller than the longest side, it couldn't connect to form a triangle. It's too short. So the smallest sides combined together had to create a measurement that was longer than the largest side. That's basically what it is. And really the truth behind it is that, hey, if I add A and B together, it should be greater than C. And if I add A and C together, it should be greater than B. And if I add B and C together, it should be greater than A. Essentially, if you add two sides together, it should be larger than the third side. But the best way to go about checking it, the quickest way to check it, is just to focus on the two smallest combined need to be greater than the largest. If the two smallest combined is greater than the largest, then it's always going to be a triangle. Okay? All right. So in this case, if I give you a triangle in which I've got 5, 9, and 14, I want to know, is this a triangle or not? Is it truly going to be a triangle or not? So the quickest thing, again, is to focus on my two smallest sides. So what are my two smallest sides?
5 and 9.
5 and 9. So my two smallest sides are 5 and 9. So if I add 5 and 9 together, that's going to come out to 14, which is equal. That's equal to 14. So is that going to form a triangle? No.
No.
Not a triangle. Even though, hey, I could add 14 and 9 together, that's going to be bigger than 5. I could add 5 and 14 together, that's bigger than 9. But 5 and 9 together is not bigger than 14. So that's where the problem comes. Has to be bigger than the largest side. Okay? All right, let's go to cross sections. That's the next item that everybody seemed to have some concerns about. So I want to make sure that you guys have an understanding. Cross sections is actually very, very easy, but you have to have a memorization of a couple of key words. So if I say that something is parallel, so let's talk about prisms first. So the idea of prisms is you have two congruent bases. Who can tell me, what does congruent mean? If I say it's congruent, what is that? What's another word for congruent?
Equal?
Equal. Another word for congruent is equal. So you have two equal or two exactly the same bases. So like maybe it's a triangle. That's your base, and then it's connected together. So there's a prism. That's a prism. Two triangles. A cylinder is not technically a prism because it doesn't have edges, but it's kind of similar to the idea. Okay, it has two congruent bases connected by one rectangle that wraps around. A rectangular prism, you've got two congruent rectangles that are going to connect together. So you've got all sorts of different ones that you can draw as long as it's got two bases that are exactly the same. Okay, and then we've got pyramids. So if we talk about pyramids, pyramid has one base and a vertex. Okay, so with prisms, we had two congruent bases, and then we had rectangles to connect, right? Those rectangles were going to connect our bases together. Here, with the pyramid, you've got one base. How do you think the base connects to the vertex? What shape connects the bases to the vertex?
The triangle?
Triangle, yeah. So it has one base and a vertex connected by triangles. Okay, so I might have a rectangular pyramid. So I've got triangles that are going to be formed. You see these triangles coming up, formed to connect my base to my vertex. It's the same idea for a cone. You might not be able to always see the triangle very easily, but it's one triangle that kind of connects to a vertex that wraps around the cone. I can have a triangular pyramid. Okay, so it's a bunch of triangles connecting this triangle base to a vertex. So those are all pyramids, has one base. So now, if you do a cross section, if you talk about parallel to the base. So in the cross section video, I talked about how parallel to the base means you do not touch the base at all, right? The base stays completely intact. So it's kind of like if you slice butter. If you cut butter and take it apart, you're going to see a very similar shape being presented to you. If you slice if you have circular salamis that you're slicing these slices of salami, it's going to come out with these circular shapes for you. So whenever you are doing a parallel to the base kind of cut, you're going to get the base shape. So whether it's a prism or pyramid, it does not matter. For prism or pyramid, it'll equal the base shape. As long as it's parallel, for a prism or a pyramid, you're gonna get your base shape. So if it's a triangular pyramid, it's gonna be a triangle. If it's a cylinder, it's gonna be a circle. If it's a rectangular pyramid, it's gonna be a rectangle. So whatever your base shape is, that's what's going to be your cross section if it's parallel. You have to remember these key words. Parallel will give you your base shape. If it is perpendicular, to the base means it actually is going to slice right through the base shape. So here, perpendicular through this cylinder, it's going to cut right through the cylinder. Perpendicular to this triangular pyramid is going to slice right through that triangle's base. Okay, so it cuts right through it. That's what perpendicular means. So when it's perpendicular, if it's a prism, if your shape is a prism, meaning you have two bases, then you're going to have a rectangle. Always. If it's a pyramid, meaning you only had one base and you did a perpendicular cut, it's going to be a triangle. Oh. And now I mentioned that there is one shape that it does not matter how you cut it, you will always get a single cross section. Who can remember what shape is it and what cross section is it?
Where?
Wait. For what?
Cube?
What shape? So what three-dimensional shape? So I've given you a whole bunch of shapes here, but I did not list the shapes that exist.
Cube?
Not a cube, but a sphere. If we take a sphere, no matter how you cut a sphere, what kind of cross section do you think we're always going to get?
A
Circle?
A circle, sphere, all cross sections. are circles.
Mhm.
Always, always, always. It does not matter how you cut a sphere, that cross section is always going to be a circle. Okay?
Mm-hmm.
So that's it. That's it for my review. So now's the time for you guys to go ahead and if you have questions, you can unmute yourself. You can ask questions, and I'm more than happy to go over those. Now remember, I'm not currently not in able to see if you're typing in a chat. I can't see you're typing.
Would it be would it be questions where like it talks about like the measurements and like it's just like parallel to like the base, and then it talks about the measurements, and you have to figure out which one's like the right one, the right.
Are you talking about for the Prodigy game today?
Yeah, would that be like on a test or something?
No,
Like
they're not going to have anything that deep. The Prodigy, and the only thing that I could do to assign for the Prodigy, it had to include measurements as well. But when you're taking your test tomorrow, your test is literally going to be describing what two-dimensional shapes can you get, or comparing, saying, okay, hey, you can get the same cross section with this shape as you do with another shape, or you are not able to get this kind of cross section. So it's mainly focusing on what two-dimensional shape can you get from these three-dimensional figures.
Also, the test is tomorrow?
The test is not tomorrow. Fridays are always catch-up days. Your test is going to be next week, most likely on either Tuesday or Wednesday, but it's an open test. So if you don't have a chance to get to it on Tuesday, you can get to it Wednesday, or depending on what day I assign it. We do want you to try and do it the very day that it's assigned, but there are a few people who have not been caught up with their assignments yet. They might be lagging behind a little bit. So the best thing you can do is take it as soon as you can.
And wait, so that will be like digital learning for that day for your class?
That would be what?
Like digital learning for that day?
Yes,
Like,
that would be the digital learning for that day. It would just be the test.
Yay.
Sanaya, you have a question, honey? It says you've raised your hand. I'm trying to find you. Do you have a question, Sanaya?
What
No?
if, like, you have to try to, what if you have to solve a type of problem, long problem for, like, the triangles?
Like if you have to solve for the so you want me to go back to triangles?
Mm-hmm.
Okay, so for the triangle problems, are you talking about the solving for an angle?
Yeah.
So it's always just going to be the same setup. You take all three angle measurements that they give to you, and you set them as an addition problem, and it's equal to 180. So it does not matter what kind of angle measurements are being placed there. Maybe it might just be an x and two numbers, and you would have x plus two numbers equals 180. Maybe it might be a 2x and a 4x and a number. You would just still combine your like terms and set it equal to 180 and then just solve. Jimmy, honey, I need you to stop humming. It's just like class all over again. Does that help answer your question, Sanaya?
Yeah.
Okay. Are there any other questions? If you guys need anything else right now, anything I can answer for you? If not, you can log off if you're good. Okay, so everybody's still so quiet. So I'm going to go ahead and assume that you are good to go. You can text me if you have any other questions. and good luck. Okay?
Okay.
All right. Bye, guys.
Bye.
Bye.